One case in which one might want to get genetically tested is to see if they're a carrier for a certain disease and what the probability is they're going to pass that disease to their child. This is a problem involving pedigrees and Punnett squares. Pedigrees are a common thing that a genetic counselor may help a family with. In this problem, we see two couples with some disease incidence. In this case, the disease is autosomal recessive. We're going to call the allele A. That means this person's genotype must be little a, little a. We're also going to say their partner is heterozygous, big A, little a, which also means they are a carrier. They have one of the disease alleles, but they don't exhibit any symptoms. For the other pair, we see a homozygous dominant, no disease alleles, and another carrier. Now each of these pairs has a child. And this pair right here is the one wanting to know what the probability is that they're going to have a diseased offspring. Now, the first step to this problem is finding out the probabilities that each of these parents is a carrier. So, we use a Punnett square to determine big A from the mom and big A little a from the dad. We see that there is a 50% chance that this individual is going to be a carrier. Over on this side, we have the diseased individual, little a, and another carrier, big A, little a. We see a 50% carrier and 50% diseased phenotype. Since we know this individual is not diseased, we don't need to count that. We see that there is a 100% chance that this individual is a carrier. Now we need to determine the probability that if both of the parents are carriers, that their child will have the disease. You see right here, this is the only incidence where the child could have the disease. 1 in 4 is 25%. So now, to determine what this probability is of having a diseased offspring, we use the product rule. The probability that dad is a carrier, 1. The probability that mom is a carrier, 0.5. And the probability that if they're both carriers, they will have a diseased offspring, which is 0.25. If you multiply that all together, you get 0.125, or a 12.5% chance that this individual will be diseased. Now, where genetic testing comes into play, if the mother was tested and it was determined that she was indeed a carrier, this would go up to 100%. This would make the entire equation 1 times 1 times 0.25. This would give this individual a 25% chance of being diseased.